Well, hey, everybody. This is Cosmic. It's 2 hours UTC, and it's the 3rd of February, 2018. And here I am, a little bit of a surprise. Said I wasn't going to be here, and I am. So, yeah, a little change in plans. Going to the art show. Decided to not attend primarily because I'm pretty far out. I'm pretty far out, so it's about a little over an hour's drive door to door and one way, and that seemed a little too far. Really, the only reason uh, I want to go is because I want to see everybody else's work. I want to see, you know, what others are doing in sort of the same uh, uh, thought pattern in terms of creating art from data. So definitely want to see that, but I couldn't justify going in. Um, so I'm going in twice. So decided that since really it's all I really want to do is um, see all the other artwork. I will just go in at the end on Sunday so I can see all the artwork and then I can grab my stuff and go. Um, Little piece of interesting late breaking news. I just got an email about a half an hour ago with a offer to purchase one of the pieces uh, that I submitted. So of course I'm going to accept that offer, and yeah, so I thought that was kind of interesting and exciting. The piece that is going to be purchased is not the piece that got um, the uh, honorable mention. Um, so that's a different thing altogether. That's an award. So yeah, very very cool. Hope everybody's doing well. I'm kind of I want to see if I'm actually live because I'm not seeing any viewers. So I'm just going to look at my YouTube. Oh, it says that I'm live. It says that I'm live. Yep, yep, yep. There it is. There it is, picking his nose. All right, that sounds good. I just don't have a viewer count. So I'm going to go to the chat. I'm going to open up chat and see what we're doing there. So this is Astronomy Daily Live, happening every single day at 2 hours UTC. This is just a casual, yet hopefully high quality coming together every single day. Just a circle of friends that sit around for an hour or so and talk astronomy. And I'm trying to see if my live stream, it's interesting. Oh, there it is. Um, I was going to say my live stream was showing up on my smartphone, but not on my Linux machine. Yeah, that doesn't make any sense. All right, so I'm slowly getting into the chat. Slowly getting into the chat. Uncle Bill, hey, nice to see you. I saw you in the chat a little bit earlier, so yeah, thanks for hanging in there. Um, I think it's pretty pretty neat that last night you dozed off during my show. I consider that an honor because I I was able, to sort of get into perhaps areas of your consciousness that I normally wouldn't be able to get into. So that is indeed an honor to have been able to do that. So yeah, this is just a very, very casual gathering of friends, getting away from the TV and the news and focusing on something that I am indeed passionate about. And if you are watching this either in the present or in the future, then hey there in the future. This is the past. It was pretty good. I hope the future is as good. So nice to see everybody in the future. Understood, Uncle Jay, that Big J is doing Python tonight. He's doing some Python programming tonight. I think just getting into the basics, if I understand correctly. But hey, it's awesome. Python. I first wrote my first Python code probably, it's got to be maybe 22 years ago, something like that. Python was first developed in the late 80s, early 90s. So I didn't really come across it until maybe 90, 96, 97, 98. Don't remember exactly when. It was uh, a graduate student was interested in doing some benchtop experiments on determining using an optical interferometer, determining how deep of a null she could create, and given certain physical conditions with the optics and the atmosphere and all of that, um, set up what's called a PID loop, and I could probably look up what that is because I haven't thought about that in a long, long, long time. But it's a feedback loop for control systems, and it required a camera, a CCD camera, and some piezoelectric um, like piezoelectric motors to move things, in very, very small steps, nanometer scale steps, and it all had to be actively controlled because you had to lock on to the null and then be able to track the null, and that required changing things. Anyway, the control software and the um, acquisition software for the camera was all written in C, and I could create a DLL file that had all the functions in it. And luckily enough, well, and I had just sort of been introduced to Python, and I noticed that it created some pretty nifty and pretty easy user interface types of things, sliders and buttons and those kinds of things, image display, whole bunch of stuff, right? So I built the entire control system in Python, but to control the camera and to grab the images off the camera, I had to link the Python code and the C code. And luckily, I think a lot of languages do this now, but luckily at the time, Python had that ability, and so it was super, super easy, to write sort of the wrapper code um, to take care of that. So I love Python. Yeah, Python is one of those great um, languages. It's a pretty high level language, but it's awesome. It's awesome. I haven't really used it as much as I want to. Um, Most of the time, uh, I do things. I get into things based on need as opposed to just sort of the academic exercise. I'm not really into academic um, exercises. I want to the the way that I learn is by solving a problem. So I want to um, look at a certain set of data in a particular way and do the analysis in a particular way. And at the same time, I want to learn a programming language or a paradigm or something like that. So get to solve an interesting problem, and um, uh, and I learn software at the same time. So you know uh, the thing about learning software is just about like learning anything else. It's just sort of repetition. You just have to keep doing it, and I find at least that um, my motivation for that comes from solving a problem that I am interested in solving. And if I do that, then I can keep on it, and I don't get bored or frustrated or anything because it's a problem I'm trying to solve. And damn it, I'm going to solve it, and I'm going to use this code or this procedure or whatever it is, and that allows me to sort of do both things at the same time, and I double up on the learning curve, and that seems to work really really well for me. So yeah, I love Python. Love Python. So pretty much anything goes in this live stream. There's really no pressure to cover any news. If there is anything interesting, I try to bring it. Most definitely, those who are watching this live, if you've heard anything, um, any interesting news, any interesting observations that you've made in terms of what's going on in the astronomical world. Love to hear about that kind of stuff. I try to keep up on those kinds of things, but there's only so much time and so much effort. I've got a job to hold down, and I have my own research that I want to be doing, and um, and then evenings are more for relaxing and coming into the circle and talking about astronomy in a passionate and informative and exciting way every single day. But I'm skeptical, and I suggest that you also be skeptical, but also be open-minded, and don't throw things out just because they sound strange or sound completely impossible or completely stupid or something else, right? Hmm. Connectivity. Okay. Looks like I've. Oh no, I'm good. I'm good here. Um, Required basic. Yeah. Yeah. I didn't get much into the assembly language, and that's something I sort of regret. I definitely can, but as I said, I usually do things out of need, and not just for the academic exercise, and so I've never had a need to do um, assembly language for any chip at all. I've always been able to get away with other languages, primarily C. C, as far as I'm concerned, plain old vanilla C is, at least in my limited experience, the greatest programming language ever. I think it's great, and I'm not a big fan of object-oriented programming. I understand the paradigm, and that's pretty much all it is. It's just a different way uh, of looking at things, and I appreciate that. I appreciate that. I personally don't think that that is a necessary layer. Um, you can do everything in C that you can do in C++ or any of the other object-oriented programming languages. Um, Other languages have advantages, perhaps, that C doesn't have, like Java, right? It's cross-platform automatically. So that's nice and that's cool. I don't know if it's if if that's really the only cool, nice thing about Java. I'm not quite sure if forcing me into OOP, object-oriented programming. I don't like to be forced like that. So, but you know, from another perspective, C forces you into a paradigm. It's just, I'm biased, and so yeah, I guess I prefer the C paradigm where it's just basically just functions, um, as opposed to the object-oriented um, paradigm, which are classes and objects and methods. So, you know, whatever gets the job done is what I am in favor. If it gets the job done, then uh, I have no problem with any of that. I just lean towards just plain old C. But I'm really into Perl. In fact, I'm going to show you a little thing tonight, um, hopefully in a few minutes. Some very interesting thing that I did with Perl today. But this is just a daily live casual show. We can do Q&A if you wish. If you've got some questions, you're new into astronomy and have some questions, and there's a lot of information out there now. So I can certainly be a source of information, maybe point you in some kind of a direction. Uh, yeah, yeah. So uh, use this thing as a resource for sure. To get um, answers at least as well as I can uh, to some of your questions. But we can talk about other things too. We can talk about telescopes or observing or um, uh, analyzing data or collecting data, the different kind of instrumentation, CCDs, spectrometers, photometers, polarimeters, combinations thereof, um, uh, any astronomical instrumentation, like adaptive optics. You want to get into that? Uh, yeah, anything like that. Any gear, any institutions, be it universities, private institutions, government institutions. We can talk about what astronomers do, uh, what the process of observing is. There's a lot of astronomers who will never go to a telescope at all, ever. They just they work on theory and computer science, that kind of stuff. Good good stuff. We need we need the models in order to play around. We kind of create a virtual world, and we can play with some of the knobs, and yeah, that kind of work can last lifetimes, absolutely lifetimes and lifetimes. So tonight I'm back to hydrogen hydroxide for the drink of choice. Cheers. Oh, I'm gonna lose my screen here. Who? Let me get it back. There we go. Yeah, it's compiled executables are is is just assembly code. That's all it is. It's exactly what the CPU for that machine wants to see in order to execute the program. So an executable is faster because it has saved a step. The interpreted languages like Perl and Basic, Python, and all those, there's at least one extra layer because eventually somehow you have to take that Python code and you have to translate. Sorry about that. You have to translate it to machine code. You have to do that sometime. So, but yeah, interpreted tend to run slower uh, than compiled. Yeah, for for sure. But there, yeah, you know, as I said, I I sort of I'm a programmer that will use the language that I need. The functionality that I need, um, rather than, it's like, okay, look, I am a staunch C guy, so screw everything else, you know, not not going to do it. It's like, no, one, uh, as I said, based on need, what programming language or paradigm is going to get the job done in the best way as fast as I can because I'm really excited and I want it done. Uh, but then there was another point there. I hate that. Hydrogen hydroxide may fix it. Yeah, Uncle Bill, that was me. Um, the Facebook group um, is called Smartphone Astronomy, and they're a very active group. I mean, several posts per day, and one or two or three or four new members every day. It's a very active group. They're doing some really cool stuff. Um, that group has inspired me to get into um, writing apps. Never written an app before. I've got a Samsung Galaxy S7 running Android, and I have, um, you know, again, it goes back to I've never had a need to write an app, and I'm not going to do it just as an academic exercise. I don't learn things that way. So, um, uh, so, but I I got this smartphone almost a year ago now, and I've had a few ideas for apps that I want, to do actually some I guess you call it real science. Yeah, I'm absolutely convinced that these cameras, these devices are good enough to be able to do real science. In fact, I did do real science with this smartphone camera, which was the motivation for me to get one. Up until then, I had no need for a smartphone or anything like that, so I don't have one. And even as it is, this smartphone isn't a phone because it doesn't have a plan. It connects to the internet, and it has all these really cool internal devices like cameras and magnetometers and thermometers and I don't know what else. There's all kinds of sensory input, and that means data. And when I see that, it's like, ooh, I'm going to grab onto that. So yeah, I did some science work with that in the spring of 2017 last year. I'm not going to talk about it now. Don't want to bog you down. But yeah, that was me. And I reached out to that group for the Distance to the Moon project, and I got a lot of response there. I'm about to push the button on that project. Um, I'm going to have to let this kitty in, otherwise she's going to drive me insane. So I will be right back. Uh, excuse me, just for a sec. Okay. Yeah, I'm really really impressed with the smartphone that I have. It's uh, the camera can output the images in this raw format. So I've got the red and the green and the blue pixels, and so I can extract just the reds or just the greens or just the blues. I can do I mean it's I can do flat fields, I can do darks, I can have fully calibrated data with this thing. So yeah, it's really really awesome. Anyway, they've inspired me. They um, they're extremely limited with the at least on the Android side. They're extremely limited in terms of apps. Cat, come on, chill, dude. Um, Extremely limited. So that really motivates me a lot because if there's a need, then that's a hole, that's a vacuum. I would love to fill that. So yeah, I've just started getting into the app development, and I think I was looking at this a little while ago and sort of lost interest because I didn't have a strong enough motivation, but now I do. Now I do for sure. There are people, um, a large number of people who would absolutely love to have an app to do astronomical um, things, not just a better means of taking astronomical photos, but I'm thinking processing the images, stacking them, um, doing some basic image processing, uh, which I have a lot of experience in, a lot of experience in doing that. So it's no problem for me to write all the code to do that. So yeah, I'm thinking plotting. Um, yeah, sky's the limit, really. So, but yeah, I think the first thing is just to get sort of uh, an, a camera app that can sort of do what the default camera app does. Change exposure times and change ISOs and really really dive into the camera API and see what's available in terms of control. Is a 10-second exposure? Is that as long as I can go, or can I do as long as an exposure as I want? If I can do as long of an exposure as I want, that opens up huge, huge possibilities because you can do a long exposure, and if you guide, just awesome, absolutely, absolutely fantastic, and um, video the same thing. So there's lots of possibilities there. Yeah, I do have a cell phone. It's just an emergency phone that I keep in my vehicle and I keep it off, and it is never ever ever used unless we need to uh, uh, recharge it up with some minutes or uh, or if there's an emergency. So that's what it's for, and it's a flip phone too. It's just you get it cheap, and that's it. But so technically I do have a cell phone, but not really. I mean, it, it's never used. It's never ever used. All right, well, cool. Let me show you. I got a series of comments on uh, one of the live streams from a couple of days ago from the user Astro-B, and he was commenting on uh, basically my use of language, and yeah, I have to agree that it's a little sloppy and lots of ums and ahs, and that's something that can definitely be worked on for sure. And maybe you're even seeing a reduction in those kinds of things on today's show, just like the that I just did. So yeah, totally aware of those. Have been for a while. Never needed to really worry about that. Now I need to worry about it a little bit more because that can be pretty annoying for sure. So don't want to reduce the quality of the content by the quality of the delivery. I am more or less, just a messenger, but delivery counts to a certain extent. If it's, if there's too much noise, it's hard to hear. So I got you. But he inspired me to do something that I've been wanting to do for quite a while, but again, have never had the need to do it. And what Astro B inspired me to do, and I'm going to share my screen here. So I'm going to go to infinity. We're going to hide that. We're going to bring this up. So what YouTube can do is YouTube can create a can create a translation. Um, what is that called? A translation? It's not a translation. It's a what is that called? I'll get it here. A translation, I guess. Yeah. I mean, where YouTube has uh, listened to me talking and converted that to um, uh, text. So what I've done is I've written a little Perl script to uh, count how many of a particular word uh, at least the translator or the transcriber uh, reports that I've said. So on the left here, and maybe I can zoom in. Cool. So on the left here, you'll see that there are words: ages, Arizona, art, astro, awards, C, daily, just goes on, right? So these are all the words that the YouTube transcriber thinks that I've said. And I can, so, and on the right is is the little Perl script that I wrote, just added up how many times I said ages and how many times I said Arizona and how many times I said art, blah, 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 blah. Right. So you go down this list and, I said apparently the word field 5 times, said the word I 339 times, said the name Katie 9 times. Hey, OMC Triple X, nice to see you. I'm really nerding out tonight. This is I've let YouTube transcribe last night's show and turn it all into words, and then I wrote a Perl script to count the number of times that word was at least, the translator heard me say that word. So I said the word sun 16 times, said the word thunderbolts once, said UTC 4 times. I said A 219 times. I said about 50 times. Isn't this cool? Kind of interesting to see uh, what words are said. I actually went through, and I'll get that info over here. I actually just created a little table, and I added up the number of words that the translator, this transcriber, heard me say, and I said 8,800 words last night. And on average, I said each word a little over 7 times. That's a very, very poor estimate, right? Because I mean, it can go from on this thing. The only way it's going to show up is if it's at least there once, and then it can go all the way up. So it's just kind of interesting to see the structure. And I made some plots. I don't have them here, but if I look at sort of the distribution of words, um, every day has basically the same pattern to it. The same words have basically the same, it's the same number of times that those words have been said. See, so look, the word astronomy last night, I said it 11 times, at least according to the translator. I said astronomical 5 times, and astronomers 5 times, and astronomer twice, astrophysics once. So if you add this up, see, that's 12, that's 23, that's 24, 24 times I said something with the word astronomy in it last night. So I just think this is kind of neat, and it was inspired by AstroBee's suggestion that my delivery can be much improved. And I've got to agree with you that that's absolutely true. I think if I have enough time to iron everything out, make it nice and smooth, I think it'll be greatly enjoyed, and it'll be a win-win for all of us, for sure. Anyway, I just think this, nerding out to this kind of strange data, right? It's the number of times that I said a particular word in last night's live stream. And it's kind of interesting what words at least it thinks that I said, because I can go back in my memory and I can question myself and say, did I say the word beep? I mean, according to this, I said the word beep once last night. So yeah, I don't know what that's all about. Don't know at all. But last night there were 1,250 unique words. So I might have said the word "you" 317 times, but that just counts as one unique word. Well, I said 1,250 unique words last night, and that's what all these are. So I said billion 17 times, said biological twice. So I'm going to keep, I'm going to nerd out in a serious way, and I'm going to sort of keep track of these over time, and see what they do, see see if there's consistency. Do some science on it. Calculator was said twice. Can said 42 times. Choose, chemistry, cheese. Check out. That's awesome. Collapse, collide, common, complex. I said complicated 6 times according to that thing. Hope this is moderately interesting. I just sort of, it's neat where inspiration comes from sometimes, and this was Astro B's doing. Total shout out to Astro B for inspiring this, because this is something that I've wanted to do for a long time and never really had what I would call, decent data. I mean, I could take Shakespeare, say, now and run it through this. And yeah, okay, that'd be really, really interesting to see what the results are. But this, this is a little bit more personal, because it's what I'm saying like right now is going to be counted, and it's really, really interesting to look, uh, to be able to look this up and you know sort of maybe get an idea of where the focus of the show was. Data, data, I said 6 times. Day, I said 8 times. Let's see what else. I'm only in the D's. It just goes on and on and on here. I'm going to skip down a little bit because maybe this is getting a little boring. I said million 16 times. I said more 33 times. Most, movie, naughty. I said naughty twice. Did I? See, I look at these and it's like, did I really say that? I said no 17 times. That's pretty good. Nowhere once. Now 18 times. Of. Okay. I said okay 26 times. It's really interesting. It's kind of interesting. It's a different, like, maybe it's sort of a different way of looking at things. And I always appreciate that. I hope you do a little bit. It's nerdy. It's, you know, seriously, seriously you know, leaning into the nerd. I said probably 15 times. I said pretty 29 times. Wow. It has as I said, an average, on average, I said every word 7 times. And it's got a big deviation though, plus or minus 25 times. So anything, saying something 69 times is that's a uh, that's that's a very, very large number for sure. I said red 8 times, right 36 times. See, I think the most largest value that I've got here is this one right there. U. So I say, last night I said U 317 times. And that's, you know, if that's relatively close to what it to how many times how many times I actually did say it, I think that's pretty good. I think that's pretty good. That I'm saying you, I'm focusing on you. I think that's pretty neat. That's sort of almost where I want to be. Yeah, I think I do I might say I too often. I guess what I hear a lot of others doing is saying we are doing this and we are doing that when it's only like one person there. So yeah, and I guess it's my show, so maybe I'm saying I because it's my show. I don't know if I necessarily see that as a bad thing or not. I assume that you're thinking that that is sort of a thing that I should work on a bit. So yeah, I'll think about that. Think about that for sure. Anyway, I just sort of thought that you all might be interested in seeing some of the nerdy things that I look at from time to time, and I think this will be an ongoing thing for a while. I've already got lots of data. I'm going into my ending my third week of this, so pretty soon I'm going to not remember how long it's been. So it's still new enough that yeah, I think I'm finishing my third week or starting my third week. I don't, yeah, maybe I'm beginning to not remember that. It doesn't really matter because we're just here. I am just here. We are just here every single day. Nice circle of friends talking astronomy and other nerdy things. Yeah. All right. Well, let me get out of that. How do I do that? I've got to do that. And then I can go over here, and I can go here, and I can go stop sharing. And there I'm back. Yay. Very cool. So anything interesting astronomical going on? You know, there were some things that I wanted to talk about last night, and I the discussion was really good, so I didn't, and now I don't remember what exactly those topics were. Oh, I wanted to maybe go through archive.org with you folks and see if there's anything interesting there. um, what else can I look at? I'm gonna look at my notes a little bit. Dun, 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 dun. Quit out of there. I'm over on my Linux machine. I'm going to go that file instead. Get some hydrogen hydroxide down the pipe. Hope everybody gets a chance to listen to music from the hearts of space. If you're into astronomy, you'll probably be into music from the hearts of space. If you aren't already or haven't heard of it, definitely check them out. They huge shout out to them. They've been part of my life since the mid '80s. They started as just a local show in San Francisco, I think in the early '80s, when electronic music was starting to sort of get out of its infancy and into some more interesting areas. And so they started a local show that went national like around 85, 86. I don't remember exactly when. And that's when they started being played on the local um, PBS radio channels or the public channels. And it was a week. It is and it was a weekly show, not always a new show. Sometimes there are repeats. There's over 1,100. I think this last week's show was 1,170. So there's 1,170 unique shows, and then a lot of the weekly shows have been repeats. But uh, they do have a weekly show, oftentimes new, and on Sundays that weekly show is free. So you can go to hos.com, and you might have to create an account in order to listen to the free show. So nothing's ever free. So you got to give a little bit, but you get yourself on a pretty cool list, and I think you can get email notices and all that kind of stuff. You can also subscribe. So there's a subscription service too. There are different levels where you have uh, partial access, different levels of partial access, and then there's a full access one. It's like $100 a year or so. good deal. Um, I've I've done that a while, and yeah, it's awesome, especially to catch up, or if you just want to listen to some nice, relaxing, spacey sounding music. They also do cultural uh, sounds from around the world. Really, really awesome stuff. It's not always awesome, but most of the time it is. So yeah, check that out for sure. Big shout out to Hearts of Space. They've been blowing my mind for a really long time. Inspired me, to get more into composition for that kind of genre, which I do. I wish I could do it more, and maybe with the right kind of support, I can have a little bit more time to work on those kinds of creative things, and yeah, who knows? Who knows? Let's see. Let me look at the chat. Make sure that I'm not missing anything. Not missing anything. Good. Hey there, Tom. If you're still in, I don't think I've said hi yet. So glad you could come by. Maybe you're still here. Maybe you're not. I don't have a viewer count on my little doodah here tonight, so don't quite know what's going on there. But I am going live, so I mean I can see my live stream over here. So I think I'm good with that. So I'm not going to sweat that too much. So yeah, let's fly over to archive.org and see what the latest papers coming out are looking like. Hope that's hope that's okay with everyone. It's usually some pretty interesting stuff. So I want to go over here, and then I want to go up here, and I want to do this. Archive.org, huge shout out to them. You guys are awesome. Thank you for doing this. This is a incredible resource for people like myself that don't have any other means of access. I'm not at the moment not associated with any academic institution, so I have no privileges to to peer into um, sort of the normal routes. So this is an alternative. These these papers are technically like preprints. They these papers have been accepted for publication but haven't been officially published in those publications yet. But once they're accepted, a lot of authors are opting to get that out right away. And in today's world with the internet, why not? Scientists, if there's one thing pretty consistent with scientists is that they really want to let everybody know about their work and they want them to know right away. And that's really awesome because information gets shared uh, rapidly and with extremely high density. So let's just look at the newest ones here. These are updated every single day. You'll get a couple of dozen new papers every single day. So this is really, sort of the bleeding edge. It's the cutting edge of, in this case, astronomy. Archive.org does all kinds of stuff. They do all kinds of physics, mathematics, statistics, economics, uh, seismology, I think. We can go back and look here. Uh, so physics, mathematics, computer science, biology, finance, statistics, economics. It's awesome stuff. But rightly so, wouldn't you agree that astrophysics is the first one on the top? They they put the best one at the top. Wouldn't you agree? So I'm just gonna I haven't looked at these today. at all. So let's just sort of see what they're talking about. Magnetic fields are mentioned in the first two papers. Spiral arms, warping, and clumps. Massive survey. Paper number 10. That's what that X means right there. That's paper number 10. So this is a series. Got to go back and read 1 through 9. It's like a you know, back in the day with the sci-fi, how each magazine issue would have a chapter. That's sort of like what these are. So you got to go back and read all those things. Velocity gradient amplitudes, theory and observations. I think that's an O6 absorber. That's oxygen 6, I believe. It's cool because, if any of these titles, I look at the titles. I start with the titles, and if there's anything that sounds interesting there, then I'll dive into the abstract. And this is the abstract, these paragraphs. It's usually just a paragraph, which is just a summary of the whole thing. So it's a very, very compact, um, very, very abstract, usually, literally and figuratively. Revealing the velocity structure of the planetary nebula in its entirety. That's kind of interesting. Um, Probing planets in extragalactic galaxies with quasar microlensing. That's just, it's amazing what people are doing. And a lot of it just sounds just so cool. A lot of it's like, well, okay, but a lot of it is really just like mind blowing. Asymmetric emission of the O3 5007 profile, Seifert 1 galaxies. Role of convection across the HR diagram, Hertzsprung-Russell diagram. A whirling plane of satellite galaxies around Centaurus A challenges cold dark matter cosmology. Cool, I love challenges. I love it when we're challenged. Extreme gravitational lensing of the quiescent galaxy at z equals 1.6. Z is a measure of so-called redshift. Your model, on the biohabitability of M dwarf planets. GPU accelerated manifold creation method for spinning compact binaries. I always thought reading these and saying them out loud just made me like sound really smart. I still think that. H alpha and H beta Raman scattering line profiles of the symbiotic star AG PEG. Huh. Powerful solar flares of September 2017. Liquid mirror telescope. Weren't we? Somebody was talking about a liquid mirror telescope just the other day on this show. So this is a liquid mirror, a 4 meter. Holy shit! 4 meter liquid mirror telescope? No way. We gotta see this. We gotta see this. I'm gonna zoom in here. Oh, yeah, am I? Yeah, I can zoom in this way. All right, so let's take a closer look at this. Wow. 4 meter international liquid mirror telescope will soon become operational. It's in India. It's coupled with a 4K by 4K CCD, reach approximately magnitude 22.8, 22.3, and 21.4 in those spectral bands. Limited magnitudes can be further improved by co-adding. The uniqueness to observe the same sky region by looking towards the zenith direction every night makes the ILMT a unique instrument to detect new supernovae. Yeah, transit instruments aren't new, but it is, it allows you to get into the time domain of astronomical analysis and not just, you know, either the image domain, the spatial domain, or like the spectral domain or anything else. You can get with a transit instrument, you can get into the temporal domain, and that opens up a lot of interesting things. So high cadence observations will help to construct dense sampling, multiband supernova light curves. We discussed the importance of the ILMT facility in the context of supernova studies. So they're focusing a lot on supernova stuff. They're going to see a lot of shit with that. They're going to see a lot of cool shit with that. So all these blue things are references. So, you know, whatever they're talking about sort of in the previous sentence, this is a reference to what they're talking about that of course expands on that particular thing. So, you know, you can almost grab any random paper and just jumping from reference, you know, go to a reference here, go to that paper, find a reference in there, go to that paper, find a reference in there. You can go way, way, way back. You can actually, you know, chart the history of a concept from its beginning to its current understanding. Isn't that awesome? It's like a history lesson. Uh, and you can follow it now. All these papers, for the most part, are online. A lot of them are here at archive.org. So anyway, let's dive into this a little bit. I'm always looking for pictures. Um, here's some of the LMT will image the same strip of sky passing over it without any. Oh, is there? Okay, so the liquid mirror telescope observations are useful over the general facilities in several aspects. So unbiased imaging, inexpensive technology, 1/50th, 1/50th the cost of a conventional telescope of the same class. Continuous data flow, easy image pre-processing. Unlike conventional imaging, here image pre-processing is comparatively easier. For example, the image reduction is performed by dividing each column by a one-dimensional flat field. Cool. Yeah, yeah. So that's what they mean by pre-processing is they're just uh, calibrating the data pretty much as it comes off of the chip. That's cool. Deeper imaging. So let's see what else. I want to see pictures, man, is what I want to do. So this is a collaboration between 4 countries: Belgium, India, Canada, and Poland. Very cool. Oh, there's some pictures. So left panel, panoramic view of the ILMT site. So the 1.3 meter DFOT and the 4 meter ILMT are in the middle and the right side, respectively. So this is the ILMT facility, it looks like. Very cool. Whoop. There's any more pictures? Ooh, there's the inside. What does it say? Fisheye view of the present status of the ILMT. To protect from the dust, the air bearing and the 3-point mount were covered with a wooden box. Okay, cool. So they're using mercury as the liquid. That's cool. So here's just some parameters. 4 meter diameter. Reflectivity is 0.77. You got a 1.5 arc second full width of at half max. That's sort of the shape of the ideal point source star if you don't have any atmospheric distortions or anything. It's just an optical effect. Good resolution, 0.4 arc seconds per pixel. That is definitely you know well, it's about a factor of 3 smaller than the full width at half max. So yeah, you're sampling just about right. Yeah, but you already know that. It's good gain, good wavelength coverage. Oh, there's some more color pictures. The I element LMT limited magnitudes. So okay, cool. So yeah, they got the potential to see pretty deep. If you're able to handle a signal to noise of something low, something what is this, maybe 6 or so, then you can see the 24th magnitude in G prime. That's nice. I don't know what G prime is. We'd have to correlate that with this up here. Looks like G prime is 4750 angstrom. So that's a little bit on the blue side of green. Yeah, 4750 is really, really close to hydrogen beta, which is 4868. So yeah, that's uh, H beta is probably my favorite color of all time, and 4750 is really, really close to that. So I would probably like that color a lot. A bit of math. Always going to have math. Going to have interesting plots. So they're trying to calculate how often they're going to be able to detect supernovae. That's cool. Very cool. Since they're going to be looking pretty much at the same patch of sky every day, that just that opens up a lot of opportunity that you normally wouldn't have. Let's see, just going through this section of supernova candidates. A nice long paper. Summary and conclusions. The redshift integrated supernova rate may turn out to be very large. 5 to 15 events per second. Oh, come on. They think that they're going to be able to see 5 to 15 supernovae per second. It's not feasible to detect and observe each event. Okay, 5 to 15 events per second over the entire sky, I guess. Monitoring all of them is also almost impossible, as it will require a significant amount of telescope time. On the other hand, a regular imaging of the same strip of the sky with the ILMT will be advantageous to apply the image subtraction technique for detecting transients. So yeah, transients are anything that just randomly occur, supposedly random. And yeah, one transient event for sure is a supernova. Moreover, once a supernova is detected with the ILMT images, it will by default provide uh, dense sample light curves in different filters, because yeah, it's looking at the same thing every night. So if it has a detection tonight, it can go it can look back in the past and see what that same area looked like the night before and the night before and the night before. Uh, yeah, so that is using the temporal information to your advantage. I'm just going to go here and make sure. Yep, you can still hear me. Good, 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 good. The signal limit, uh, the single scan ILMT limiting magnitude, and that's a nice faint, very, very faint magnitude. That's pretty deep. That's not too bad, not too bad at all. Respectively, and can be increased if they co-add, right? So in this way, the ILMT survey should play an important role in supernova detection up to reasonably fainter limits, with a precise and unbiased imaging of a strip of sky at a declination equal to the latitude of the location that it's at. So yeah, the observational properties and theoretical modeling indicate that supernova light curves are mainly powered by a combination of two energy sources. See, it just gets more and more complicated. You can just do these hugely deep dives. So here's all the references. Each one of these you can go to and get the paper. Get the paper yourself. Read it for yourself. You know, this is what I do. I hear something astronomical on the news, or I read it online, and there's usually a report of the news, which is just a summary. And what I do, I don't read any of these articles. I scan them and I look for either titles or authors. And um, is anyone paying attention? Yeah, well, hopefully this is interesting to some. I cannot um, guarantee to be too entertaining all the time. So yeah, hang with me. So yeah. So anyway, nice list of references here. As I said, this is sort of a history lesson. Go all the way back. Very, very cool. I think I am going to exit exit this place for now. I'm going to do that. I'm going to stop sharing. I'm going to go back to that, and wondering if there's any other interesting topics to cover for tonight. A little bit of a surprise. Decided not to go to the art show, instead to stay home where I belong and not have to go anywhere. It's a long trip back and forth, and if I don't have to, I'd rather not. It's one of the uh, penalties, I guess, that you pay for uh, living in a remote location, is that the opportunities for uh, you know going to art shows and going to other city life activities is just almost doesn't exist out here. So that's a small price to pay. So yeah, I think I'm going to cut it off for tonight. I really don't have a set, begin and end time, but I do respect your time and appreciate it very, very much. I'm here anyway. I love to talk about astronomy. I have a passion for it. I think you all do too, and that's why you're here. Even if sometimes I put you to sleep, uh, just talking different astronomical things. I I like to talk about all of it, every aspect of it. Um, Definitely like to nerd out. If yeah, any ideas in terms of topics or Q&A, let me know. If you want to be on the panel here, you can just email me at cosmiclettuce@gmail.com. And as soon as the stream goes live, I can send you a link, and you can become one of the panelists here. And then I uh, get to listen to you for a while, and I'm looking forward to that. That's this kind of interaction. I'm hoping to be able to grow a little bit more and have some interesting live conversations. That aren't the chat, um, but yeah, you people are very cruel. Nah, I don't see anything cruel here. This is just fun, isn't it? As far as I'm concerned, it is. Anyway, so I'm gonna get out. I'm gonna exit towards that away, and but I will definitely be back tomorrow night. More Astro Talk. Anything, anything. I'll bring up anything. You can bring up anything as well. Always trying to keep track of astronomical things. What's going on? What's new? What's old? who's saying what, who's doing what. I like all that stuff. So I'm going to exit for now. Thanks for stopping in. Thanks for joining the circle. And I'm going to say peace out. And I will see you in a little less than 22 hours. All right. Take care.